Hey guys, Travis Gillespie here. In the last video we were looking at direct variation and we were really just getting a good overlook or overview of what direct variation is, and now let's actually move forward to a problem. So I'm going to just erase that information and get a problem up on the screen. So we have this growth chart here. Let's just pretend it's some student's growth chart. Alright, so we have some growth chart here, and it's some random person, and the age it's in months and the length in inches. So let's say at 3 months the person is 22 inches. At 6 months, the person is 24 inches. At 9 months, the person is 25 inches. And then let's say at 12 months to 12, the person is 27 inches. And what we want to do, we want to determine if the data that's shown here, if this shows direct variation. So does this data set show direct variation? Well, one way we could actually prove this is by creating a graph, just graphing this information. If this information produces, and in fact I'm just going to change to my line tool here, if it produces a straight line, then you have direct variation. However, if that line has some bends or curves to it, then it's not going to be direct variation. That's one way you can do this, set it up as a graph. So I'm going to get a chart up on the screen, and I'm just going to slide this over just a little bit, or slide it up just a tad here. Perfect, that should do it. Alright, so running along the x-axis here we have age, so that's age, and that age is in months. So we have 3, 6, 9, and 12. And running along this y-axis here we have length, so length, and that's in inches. Alright, so I'm just going to actually put a break in this graph, and let's start at 22. So we're going to jump all the way up to 22 and then move up to 24 and 26 and 28. Okay, so at 3 months the person's 22 inches. At 6 months the person is 24 inches, which is right about here. And then at 9 months the person, in fact before I even go to 9 months, you might be tempted to just draw a straight line between these 2 points and say, hey, you know what? I have direct variation because there's a straight line here. But remember, you need more than 2 points, because any 2 points will produce a straight line. So you at least need more than 2 points. So I'm going to put another one down here. So at 9 months they're about 25 inches, or they're at 25 inches, which is right about here. And now if I look at this and I were to connect these points and then these next points, it looks like there's a bend to this graph, and I'm actually going to plot one more point here. So at 12 months they're 27 inches, which is right about here. In fact, I'm going to double check that right after. Yep, right in the middle between 26 and 28. That's about 27 right there. We're going to see if this produces a straight line. Alright, so I'm just going to actually start at 22 and connect to the next data point here. But let's just think about this. If we had direct variation, we would continue on in a straight line because the change would be constant. And notice there's a bend in the next data point here from 6 months to 9 months. And I'm actually just going to connect these two lines just to show you the change here. Therefore, since you don't continue along a path at a constant rate, this is not direct variation. I'm going to erase that information. Alright, so now I want to show you another way of proving that this is not direct variation. We're going to use another method. So we're going to use that equation, our friend, k is equal to, and I'm going to erase that and fix it. So k is equal to, in fact, let's just write this out. K equals our ratio y over x, and I'm going to actually use another color for that. So y over x, and we can think of length as our values for y and age as our values for x that we're going to choose here. So I'm going to actually jump into one that's a little bit easier to play around with first. Let's look at this data set here. I'm going to plug 24 in for y and 6 in for x, and when we solve for 24 over 6, we're going to find that our value for k is equal to 4. So our value for k is equal to 4 here. But now let's actually go and backtrack over to this last one. Alright, so this time let's take 22. We're going to take 22 and divide 22 by 3. And in that case, what we're going to end up getting here, 22 divided by 3 is 7 1/3. So 7 1/3. But before we even put 1/3 down, once you place that 7 down, since 7 doesn't match up with 4, or the constant for this last data set that we did earlier, well, guess what? They don't match up they're not constant, or k is not constant here, and we can determine that the data set here does not show direct variation. Now another variation here, rather than dividing y by x each time, what you could do is set up cross products. So in that situation, what you would have done is taken 22 over, in fact I'm going to do that here. I'm going to just write that as 22 over 3, and we're just going to set it up as a proportion. And in fact, I'm not saying that this is equal to 24 over 6. I'm actually kind of questioning it. I'm just saying, is it equal? Are these two proportional to one another? So it looks like we might need a little bit more room. I got to get that 6 back up on the screen. So I'm going to get rid of all of this information. We don't need it anymore. I'm going to hide that chart for a minute. And let's just slide this down. Well, if I take the cross products here of 3 and 24 and 6 and 22, 6 and 22 there. Well, 6 times 22 is 132, and 3 times 4 is 72. Since these cross products aren't equal, it means these ratios aren't proportional, which tells us that each ratio will produce a different value for k.